Hello, good evening. My name is Murilo. I'm a student here at Data Science Retreat. I'm presenting my portfolio project. So it is the build guide. It's a RAG-based sustainability assistant. The goal of it is to assist architects and civil engineers for making sustainable choices for their construction projects. Let's say if they want to have a more sustainable roof or a concrete, the information out there is very difficult to come by. It's very scattered. So this is what my project is going to assist them with. Just a few numbers. So 50% of the raw materials extraction in the world is towards construction projects. And 60% of the waste generation is also attributed to construction projects. I gotta say, the first time I saw these statistics, I didn't believe them, but you guys can check it out. They're very big contributors for very unsustainable. My data is based on EPDs. I'm going to talk quite a bit about EPDs. So they're environmental product declarations. It's okay. They're standardized and independently verified documents that a company can produce that quantifies its environmental impact across many indicators and life cycle. So this would be a life cycle. So you'd have like the first project stage, the extraction, the construction, the use in the house, then the end of life. That could go either to be recycled or unfortunately become waste. And an example of an indicator would be global warming potential. There's many types. There's 30 to 40%, 30 different indicators. This one is a type that says how much this product contributes in each of these modules of the life cycle to global warming due to burning of fossil fuels, so oil, gas, and coal. The regulatory landscape is changing a lot. So these EPDs are they're voluntary for now, but in 2028, large buildings in Europe and Germany are going to have to make a carbon assessment for their projects. It's going to become mandatory for large buildings in 2028. And in 2030, it's going to be mandatory for all building projects. And where these EPDs will come in handy, because the EPDs already contain all this information about carbon emissions. So, problem. Let's say you're an architect, you're very worried. I'm going to show you the complexity of these EPDs, but they're quite complex. The information contained in them, even if an architect is an expert in his field, these sustainability indicators are very hard to understand, especially across different products, across the categories. How can I compare if one product is more sustainable than the other? There's a very time-consuming task. There's no simple way of identifying these trade-offs. And as you see, the regulatory landscape is changing so soon. They're going to have to deal with that. This is an example of an EPD. So the main thing that you can see is that there's a text sector and a tabular sector. So tabular is pretty nice. Let's say you got like all the values here. When you have all the values, sometimes they're missing values. But it can get complex quite easy. Like I said, here are the indicators in the rows, and here are the module life cycle modules. And the text data is the most important part as well for the project, because you have standardized fields, but the text that goes in these fields, they're not standardized. They're written freely by each manufacturer. So this one was nice enough to say what are the applications in a bullet point, but someone may just make like a long paragraph. Sometimes they put material, sometimes they don't. So that's one of the main problems with these texts. Like you can't, you'll be very hard to compare EPDs. Another big problem is that these EPDs, they're spread out in many databases. Ökobaudat is a database, is a German one. That's the one I'm going to focus for my project. But obviously in the future is to extend to other databases. This Ökobaudat has 1,400 data sets or 1,400 EPDs. And also, luckily, from a project, they could be retrieved by XML. So they have it on their website that you can get them by the XML for each EPD. So what's the solution? So the solution is a RAG-based sustainability assistant. Some of you may know as a RAG, some don't, some won't. But it's a retrieval augmented generation. Maybe sometimes some people already used on a ChatGPT when you inserted a document and you asked questions about this document. That's basically what it's doing. You have some PDFs or files, or also the tabular data that I was showing. And you want to add that to the question that you're going to make. So that's the data source here, the structured data. They're cut in 3-4 sentence paragraphs, so they have to be chunked because you can't put a whole book on ChatGPT or to an LLM, or it would get confused. So they're chunked in sections. They're inserted in a database, and when you need them, you retrieve these chunks. And you can create with a large language model, you can create a response. So how did I begin with the project? So I tried to get a minimum viable product as soon as possible. I did the data extraction with Selenium, extracted from this XML data, so this XML from the website with Selenium, and stored the data in a PostgreSQL database. I created the embeddings. They also went in a PostgreSQL database using an extension called PG Vector. And then with this data on hand, I created a small React front end and a fast API back end that was running on a local on my computer. My computer is not the best one, so it would take a long time. It would take up to 60 seconds for an inference. I also had a few other problems. Chunks were maybe too large. The instruction, the prompt engineering was not very good. So I'll show you the project so that you know what I'm talking about. So this is it. This is a EDP RAG assistant. It's not very pretty yet. That's an improvement on the front end I'll have to make. But let's say you can search the products. You can search by category, use case, material, product name. Let's start with an easy one. Let's check concrete. So this fetches from the database. These are the products. And you get 20 results, for example, and you can select a couple of them. And let's say one indicator. Which indicator would you be interested in? Let's take, as I said, global warming potential from fossil fuels. You hit compare. You're gonna get a result. So these are the two products. This is the life. So I'm retrieving the data for each EPD. And you have here for this category concrete, you're going to have a mean statistics about it, so a range, a mean, so that you can compare with the other ones. Doesn't change much, obviously, it's what you had before. Let's see if but you're going to get then an AI analysis from it. It takes a while because it's running online on a GPU that's also not the fastest one. Let's see. Just a second. There you go. So you have the AI analysis. Obviously, this is going to be improved, this speed, if I get more money and more hosting power. So you get an analysis, a textual analysis that's easier to understand than having to go through so many EPDs. I mean, obviously, you can take a link from this Cobaldat database, and you can get 3 links, for example, and put it on ChatGPT and ask, hey, can you analyze them for me? But obviously, this is extremely time-consuming. How are you going to get all these links? How are you going to know that you have all the items in the category that are important? So that's the added value. One of the added values of this, basically, the database and underneath. That you can ask, that you can get some decent human understandable information out of it. Here you can also ask some, you'll also be able to have a chat to be able to ask questions. Let's say, what is the production process of these products. Oops. Again, going to take a little bit. But that's one of the main things. So if you are an architect, you want to see, okay, what are the best products in this category? I had a meeting with an architect and a civil engineering as well. They helped me come up with some of the solutions that would solve their problems. So they can ask follow-up questions on the product. They can ask questions, general questions about sustainability or the indicators, or how they apply to these products. So this is so that you guys have an idea. Development. So this online inference is the LLM, right? What I was saying. So this is Ollama, a container running on a run pod. Run pod is a server that has GPUs where you can just send questions and you can get the response back. I benchmarked multiple models. I had Mistral, Llama, Gemma, Qwen 5.3. So for my use case, the best one was Mistral. That's what I ended up going up with. It gave me the most concise and consistent answers. One of the big problems was data. I think everybody here who worked in the projects, they had also problems with spotted data, for example. The database is a German database, but it's got a lot of text in English. But unfortunately, for some products, didn't have a text in English. Didn't have didn't have a field where they had the materials very well described, the use cases. So I had an LLM online, right? I had a large language model that I could easily ask questions. What did I do? So I recursively sent it questions. For example, please have all these products one by one. I don't have a translation for it, but I have here the German text. Please translate. So that's how I filled my part of my database for the missing English descriptions. For example, for the material and use case, I sent the description that you saw before for each product and say, okay, do they talk about materials here? What are the materials they have here? And so that's how I was completing my my database. Obviously, I also got some statistical summaries for faster retrieval, like you saw the mean, the max. And there was a lot of text processing and embedding as well. I didn't get only the EPDs. For example, if I want to make an informed decision or give them a good text back to the architect, to the user, I have to base that in some theory. So I also got some ISOs. I also got some guidelines on sustainable construction. Also chunked and embedded them with Python script. Those chunks were sent to the LLM already. So those chunks, I sent them as well to the LLM to see are they relevant or not for my problem, because I don't want to send a table of contents, for example, or just random numbers, just to make a nicer embedded database. And yeah. And this is the final architecture that you saw. So obviously the front end that you saw, it's in React. You can, like you saw, you can send the filters, the questions, sends to the back end, the backend Fast API. So another problem that I have is, okay, so what do I send the LLM? What does the LLM want to know to help me answer the questions? There are many types of questions, right? I can just compare two products. I can just ask a follow-up on one product. And I can just send like megabytes of information to LLM and I expect it to answer correctly. So I did a classification. So first, when the user sends a question, it's sent to the LLM to classify in 6 different categories. And depending on the category, I know, okay, this is the important data for the LLM to be able to answer this kind of question. So send the question, I get the category back. The prompt is generated specifically for this category. Okay. For this category, it comes back, send it back to LLM, and then I can give it back to the user. Should display it back to the user, as you saw. Yeah, I mean, this part I already talked about as well. The data extraction was a Selenium, and all this data is in a PostgreSQL database with PG vector. Okay, so what are the next steps? So next steps, I'll expand the data sources, so I can get EPDs from different databases in different formats, some more ISO documents, more theory. I have to benchmark different embedding strategies and LLMs. Maybe I get a faster GPU, maybe I get another database. For example, pgvector is good, but there are some other embedding databases that are more prone to the task. And obviously improve the front end and the user experience. Partnership and funding. There is already, I saw a couple of projects from the EU and Germany that they're trying to get more projects that put sustainability together with AI. There's funding for that already for the application. And I could also, my mentor was nice enough. He was already talking to somebody last week from my startup. And he said, oh, I talked about your project and somebody's already interested in that. He has a startup on circular economy. I can also collaborate with some circular economy NGOs in Berlin and elsewhere. And I have a couple of contacts of architects and engineers that I could develop together, could help me develop this. Yeah, and last point is the transferability. So EPDs don't exist only for construction products. They also exist for many kinds of projects, even some food sector. There's many kinds of EPDs. It could be transferable to these sectors as well. So that's a presentation. Thank you very much.